So you said 8, 9, 10. Okay. 8.
I don't know if I'm wrong, but wouldn't 8 just by looking at it be pi over 3?
Yes.
Okay, cool. Because it's 47 pi over 3.
So yeah, there's an easy way to do number 9 as well.
Yeah, it'd be pi over 6. Yeah. Big brain.
For once the unit circle, there's a faster method that you can learn. But still the same. Okay, so for this one, again, this is clearly outside of our between 0 and 2 pi. So I'm going to make sure to use my terminals, my coterminals, to try to get this between 0 and 2 pi. To do so, make sure whenever you add, I'm supposed to be adding 2 pi to this, but I can't add fractions that have different bases, different denominators. So this should be 2 pi over 1. So I'm actually going to add 6 pi over 3. And I'm going to end up having to do this multiple times to get this into the positives. So let's try it out. I start off with negative 47 pi over 3. Add 6 pi over 3. And again, the 2 pi, I just modify this 2 pi by that fraction. Hey guys, you want to have that conversation? Just have it quieter, please. All right, so just modifying this one. This would make it negative 47. Becomes negative 41 pi over 3. Now I'm going to keep adding 6 pi over 3 over and over again until eventually I get this positive. So in this case, it will be negative 35 pi over 3. Then negative 29 pi over 3. Negative 23 pi over 3. Negative 17 pi over 3. Negative 11 pi over 3. Negative 5 pi over 3. And then eventually this becomes just pi over 3. And because it's in the first quadrant, that's my solution. Now, what Scott is referring to is if it's on the unit circle, meaning it's either pi over 3, pi over 6, pi over 4, or pi over 2, there is a significantly faster way to always get the right solution. Now, that does not work on 6, 7, or 10, but there is a significantly faster solution every single time. As it turns out, that faster solution is in reference to the bottom number. Because that bottom number is on the unit circle, it will always have that bottom number as the bottom number for your solution. And the nice thing is, the top number will always just be a 1 as long as it's on the unit circle. When it's anything else, like pi over 5, it could be, there's going to be a 5 on the bottom, but the top could be a 1, a 2, but not a 3. Because a 3 would cause it to shift into a new part of the triangle. So again, there's like a lot of different shortcuts you could learn. We iterated that multiple times yesterday. There's a lot of shortcuts you could try out. This technique always works. If you find a faster one, try it multiple times, see if you keep getting the right solutions, and then go for it.
You look at just the first number.
For some,
pi over 3, so
all the ones in the unit circle work for that. Pi over 6, pi over 4, pi over 3, and pi over 2. But anything else, pi over 5 doesn't work that way. Sometimes it works, sometimes it doesn't.
Is there any way to like just figure out how to do the pi over 5? Like how to simplify it?
Yes. Told you, there's formulas for everything.
Sweet. You did number 6.
Number 6? Sure. It's pi over 4. Ready?
Well, yeah, because it's over 4. That's on minus 2 pi each time.
I will. Ready? Okay. 27 pi over 4. This is number 6. 27 pi over 4. So I'm going to add or subtract 2 pi every single time. Here we go. So in this case, I'm going to subtract 2 pi. But again, I cannot add or subtract 2 pi unless they have the same base. So I'm actually going to use, in this case, 27 pi over 4 minus 8 pi over 4. Again, this 8 pi over 4 is the same as 2 pi. So this is an allowable step. And this will cause us to change forms. So in this case, I'm going to do it once, giving me 19 pi over 4. I'm going to do it again, giving me 11 pi over 4. I'm going to do it again, giving me 3 pi over 4. Now at this point, I have to ask, it's between 0 and 2 pi, that's good. I want to make sure to find out what quadrant it's in so I know which steps to take. The quadrant it's in, 3 pi over 4 on the unit circle is right over here. It's clearly in the second quadrant. According to second quadrant rules, I would take pi minus my angle, so 3 pi over 4. And pi minus 3 pi over 4 is just pi over 4. Again, this is because this is in the second quadrant. So the 3 pi over 4 is the correct coterminal. But remember, it has to be in the first quadrant to be a reference angle. It has to be between 0 and pi over 2, or between 0 and 90. Otherwise, it is not a reference angle.
So I did do it right, I just didn't.
You didn't finish it. All right, and Levi, you also asked about number 8.
Yes.
And it's number, oh, sorry, that was number 8, number 9, 49, 5 or 6. The answer is 5 or 6. Ready? Am I good, Aiden?
Yeah.
Okay. I have been known in the past on like a quiz or something like we'll be having on Tuesday. Those people that remember the shortcuts and know they're the faster ways, like for example, if I have something over 4, I'll make it something that could have reduced down to something else. Like something over 6 could reduce down to something over 3 or something over 2 if you have the right number on top. In that case, you probably wouldn't notice until it was too late and you got the wrong answer because you tried to use the wrong shortcut. Because I'm a jerk sometimes. Sweet. 3? Sure. I'm going to go ahead and finish number 9 like Levi asked, and I'll do number 3 immediately afterwards, okay? 9. On top, we have 49 pi over 6. Again, this is too large. I'm going to add or subtract 2 pi, so I'm going to subtract, in this case, 12 pi over 6. Remember, I must add or subtract 2 pi, multiply by the top and bottom by 6. I get 12 pi over 6. Let's do it. In this case, I'm going to have to do it 4 times. So 49 pi over 6 minus 12 pi over 6. The first one would be 37 pi over 6. The second one would be 25 pi over 6. The third one would be 13 pi over 6. And the last one would just be pi over 6. Because the pi over 6 is in the first quadrant, I am done. Remember, it is when you're in the first quadrant, you are finished. You have the reference angle. Reference angles are always found in the first quadrant. And you asked also about number 3? Let's look at number 3 then. 1,120 degrees. Levi? We good?
Yes.
Okay. So we, number 3. 1,120. Oh, it's negative 1,120. Number 3. Negative 1,120 degrees. Again, I use coterminals to get this in the first round of numbers. So I'm going to, in this case, add 360 degrees. So I add 360 to that one. If I add 360, that would become 760 degrees. I add 360 again. This becomes negative 400 degrees. I'm going to double check. I don't want to make a mistake. That looks correct. I believe that is correct. Okay. I'm going to add one more 360. This makes this negative 40 degrees. Now, normally I told you guys you could add another one to make this positive and then use reference angles to find the correct value. In this case, I'm going to use one of the shortcuts I happen to have memorized. This is a negative 40 degrees. So the answer must be 40. And remember, it's about how far away it is from the axis. Negative 40 would be down here, 40 degrees away from the axis. So that means my solution is simply 40 degrees. To determine that the other way, it is easy to do. I just have to add another 360. That would make this angle 320 degrees, which is in the fourth quadrant. If it's in the fourth quadrant, our problem is you take 360 minus the angle, which would get you 40 degrees anyways. Remember, the definition of a reference angle is how far away it is from the axis. So you may always use that specific definition to find your solution maybe a little faster, which is what I did. And it works really well for small angles that are less than 0, so like up to negative 90. Once you get past negative 90, you have to start using the other techniques again. And again, it's just one other thing you could memorize if you wanted to. Or you can use technique. Technique always works. We did 4 of the 10 homework problems. I hope that was good. Any last minute questions? I'll think about it, Aiden. I'll think about it. For today, I don't have any homework assignment because again, it's still technically due tomorrow. What I want today is every person who has a calculator with them today or a calculator you plan on using for this class, I'd like it out at this time. I want to discuss some calculator things you need to know for this class specifically, including like where the location of certain values are, how to switch between them in case you haven't covered that already. You need to be fully comfortable in this class with your calculator. There will be problems in this class. This is a warning. Next semester, every test we take will have 2 parts. A short part where you are not allowed to use a calculator at all. You have to use reference angles. You have to use coterminals. You have to find your answers using the unit circle. There'll be other questions where will be like the larger portion, the main portion of your test will be you can use calculator as much as you want. Again, you'll have a short version of the test where it's like 2, 3, maybe 4 questions, and the regular part of the test where it's like 10, 15 parts. One part you have to use a calculator, the other you can't use a calculator at all. So you have to be fluent in both parts to pass Trig. So I want to make sure to spend some time today talking about the different calculators, how to switch between forms, how the different functions fit together, how the unit circle works, all that stuff using a calculator today. Hey. Sure.
Can you turn this into a sound?
Sure. Just placing this table up here.
The second one about the using the notes for that big test. Giving the test coming up soon.
Eventually.
For us to come up with.
Someday. I assume I'll write it to the test before the end of the year.
We're going to be in a circle test today.
Yeah.
Ooh, yeah.
But
I've been studying.
It's the college test. I said you're going to ask if we can use the notes over. And they have to answer you that.
No, that was the one for the entrance exam. You've already taken it. Did they let you use notes?
Oh.
I mean, he's referring to the Wonderlic.
Yeah.
Were you allowed to use notes at all for any of that? Okay. I didn't know, so that's why I said I would ask.
So
I never heard back on it.
it. Okay.
That was a test you need to take, so maybe. All right. For my calculator, I'm going to come up here and use my big calculator. Every calculator is similar, has similar properties, similar parts. You need to be fluent in the following basic calculator things in order to be capable of doing trig in this class. So the first couple of things. We've already had several problems that involve this stuff, so I hope all of you are already comfortable and familiar. You need to be able to quickly switch between radians and degrees. For most calculators, this involves either looking into the setup menu or the mode menu. If you are not aware, many calculators come up with different buttons based upon color. If you look up here at mine, you can see how the main numbers are in black and white, but there are also little sub numbers and letters in like blues or greens. If you have one of the Casios, these are oftentimes in, I think, oranges and black. I think those are the 2 colors for most Casios. Orange and red.
And blue.
Some blues? Perfect. Those are based on shift values. Example. If I wish to exit this screen, I have to go to the quit button. The quit button is up here in blue, above the mode button. So if I want to exit that menu, I hit the matching button, which is second, to access the quit command. It's a simple thing that some people just don't understand about their calculators. If you wish to access the secondary menus, you have to use either the second button on TIs or the shift button on your calculators. So, again, and if you want to borrow a calculator of mine, I do have calculators available, but they are TI-84s. They are these ones. And so if you are not comfortable on them, it takes time to find all the buttons. Never mind. You have to quickly switch back and forth between radians and degrees so the calculator will do the function correctly. In case you're unaware, some values do not matter. Example, sine of 0 is the same whether I am in radian or whether I am in degree. It's just how sine works. Any other value, though, there's a very high likelihood that it will be completely different. There will always be an indication on every calculator I've ever seen of what mode it is currently in. My TIs, say the word radian up here. It says up there, the word radian. If I switch it to degree, by going here and going down to degree, it says the word degree. It's hard to miss. On most Casios, they use the single letter system. R stands for radian, D stands for degree, G stands for something called gradient. It's a college thing. It's the next piece above radian. It's not much different. It is just something else. Kind of like degrees, Fahrenheit, and Kelvin. So, be able to quickly switch back and forth between the two, very necessary skill. You should never have to question where that thing is. If you're in Trig class and to borrow somebody else's calculator, that should be the first thing you need to check. How do I switch between the two? So, next thing.
Make sure your radios are on 10.
No. Alright. Your basic 3 trig functions are available on any scientific calculator you have. And your textbook, if you remember a week ago, some of the problems mentioned having to do a graphing calculator. This was an old-fashioned way of doing things. It used to be in the past, only graphing calculators had the 3 trig functions on them. Otherwise, they didn't have those. You couldn't grab a calculator and use sine, cosine, tangent unless you had a graphing calculator. Your Casios, nowadays, that is not an issue. If it doesn't explicitly say the word graph, then you can use your Casio. Those problems that use a graphing calculator to find the solution, that just means use a calculator for us. It's just they were written at an older time, so they use older language. It's the same problems. So, on your calculators, there are 3 basic trig functions, sine, cosine, and tangent, that are on every single calculator. These are the main ones. These are the ones we learned about in geometry, ones we started with in here. For almost every calculator out here, you got your main buttons. You'll notice that for all 3 of these, they open parentheses. There's a good reason for this. We will be doing calculations inside of these trig functions. You want to make sure tangent, sine, cosine, these are very much like an absolute value symbol or a square root symbol. You can have stuff inside of them doing more math. You can add things inside of a trig function. You can subtract things inside of a trig function. You can multiply, you can divide, you can do powers, you can do roots. Anything you can do to a function, you can do inside of each trig function. So you can do something like tangent of the square root of 5 minus 3. And it works. It's the same thing. We have these calculators pre-programmed to automatically open parentheses because they want you to make sure that whatever is inside of there is what's being applied to tangent. We need to close it. TI is not as nice as your guys's. We need to close it. This is being multiplied, unless you say otherwise. So if I type in something like 4, this is 4 being multiplied to the tangent, not to the actual function inside of it. So this function, I can do every single thing that I could do to a regular x value or y value or variable. I can multiply the tangent, I can divide tangent, I can add it, I can subtract it like anything else.